All right, class. So now we will focus on high blood pressure or hypertension. So what is hypertension? Hypertension is when the systolic blood pressure, so we are looking at hypertension. Hypertension is when the systolic blood pressure is greater than 140 millimeter of mercury and diastolic blood pressure is greater than 90 millimeter of mercury. Then we say hypertension. So we will first look at the baroreceptor reflex that helps to bring the blood pressure back to normal. So we will look at baroreceptor reflex first, and then we will look at the renal compensation for hypertension. Okay, so starting with the baroreceptor, you are already familiar with this diagram. You look at the heart, right? On the heart, you see the SA node, you see the AV node. You also see the baroreceptors located on the carotid sinus and the aortic sinus. So now we have high blood pressure. So we have a lot of pressure here. It's high blood pressure. Since the blood pressure in the blood vessel, specifically aorta here, is super high, obviously there is a lot of stretch on the blood vessel. Due to that stretch, the neurons, the sensory neurons that carry information to the central nervous system, they carry a lot of action potential. So a lot of information, like this center in the medulla oblongata knows that, oh my God, there is hypertension. And then as we remember, this center can actually talk to the cardiac axillary center, it can talk to the vasomotor center, and it can also talk to the cardiac inhibitory center. In this case, it will inhibit the cardiac axillary center. Obviously, you do not need to accelerate the heart now. You need to calm it down, right? So it will inhibit the axillary center. It will also inhibit the vasomotor center. Now, what will happen when the vasomotor center is inhibited? Let's take a look. When the vasomotor center is inhibited, first, it will inhibit the blood vessel contraction. Okay, so remember when we talked about the low blood pressure reflex, we did mention that this neuron will come to the blood vessel and the neuron will release epinephrine, norepinephrine. Remember that? None of those happen. So we will have inhibitory effect on the blood vessel, meaning there will be no epinephrine or norepinephrine, and that will result in the smooth muscle, of the blood vessel to relax. So there will be relaxation of smooth muscle of the blood vessels. All right. This will also go to the adrenal medulla, and it will inhibit epinephrine, norepinephrine. So we will have no epinephrine, norepinephrine released from the adrenal medulla that can work on the blood vessels or heart. Good? All right. And then the cardiac inhibitory center will be stimulated. Now what will happen? So the cardiac inhibitory center will send out neurons, and these motor neurons specifically innervate the SA node and AV node. I want you to understand one thing. In case of hypertension, the myocardium is not innervated by the parasympathetic pathway. So this is parasympathetic, right? Parasympathetic. So this parasympathetic neurons will actually release acetylcholine, which will ultimately lead to decreased heart rate and decreased blood pressure. All right. So this is one pathway. No, actually, this is one pathway. This is another pathway. And this is a third pathway. Okay. All right. So this is a baroreceptor reflex affecting hypertension. Let's talk about the renal compensation. Renal compensation for hypertension. What do we know? Okay. All right, let's get started. Okay, now we know that, what do we know? So let's start with low blood pressure situation. When we have low blood pressure, that is sensed by the JG cells. We talked about this. The JG cells causes kidneys to release renin. Renin goes to liver and converts angiotensinogen to angiotensin 1. Remember? The angiotensin 1 then goes into the lungs, and in the lungs you have ACE, an enzyme that converts angiotensin 1 to angiotensin 2. Now, remember, now we also mentioned that angiotensin 2 can work on different things. It can work on the hypothalamus. It can work on the hypothalamus to induce thirst, right? It can work on the hypothalamus to release ADH, if you remember. It can work on the adrenal gland to release aldosterone. It can also work on the blood vessels to increase vasoconstriction. We know this. Vasoconstriction. We know this. Now, listen carefully. On top of this, so this is, we know this information from hypotension, remember? On top of this, angiotensin can also work on the right atrium of the heart. It can actually, let me draw it this way. Let me erase this. Angiotensin can also work on the right atrium of the heart. What is there? In the, sorry, did I say right? In the left atrium. So this is left atrium. So angiotensin 2 can work on the left atrium. And when there is angiotensin 2 working on the left atrium, that activates specialized receptors. Called atrial natriuretic peptide, or ANP. That activates some receptors. So there are specific receptors. Let me draw these receptors. So it activates these receptors and ultimately leads to the formation of a protein, and the protein is called ANP, which is atrial natriuretic peptide. Now, why is this relevant? Whenever this ANP protein is being released from the left atrium, this ANP, what it'll do is it'll go to all these places where angiotensin 2 works, and it'll inhibit all those. It'll go to all those places and it'll inhibit all those. it'll inhibit ADH, it'll inhibit aldosterone, it'll inhibit this thirst center, it'll inhibit the muscle contraction of the blood vessels. So it'll inhibit every single thing that is affected by the angiotensin II. Therefore, that will help to lower blood pressure eventually. All right, so that was all about hypertension.